Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CACHEFLY.com.
This episode of Know-How is brought to you by SmartThings. SmartThings lets you monitor, control, and automate your home from wherever you are using your smartphone. Right now, SmartThings is offering Know-How listeners 10% off any home security or solutions kit. And you get free shipping in the United States when you go to smartthings.com/twit and use the offer code TWIT at checkout. Today on Know-How, we've got some mods for your FPV250 quadcopter. Smitty continues his Arduino clock, and we're going to talk about a hybrid supercar. Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Balliser.
And I'm Brian Burnett.
And for the next, depending on how much time we have left in our schedule, 30
minutes
to 60, 10 minutes, we're going to be talking about some of the projects that we've been playing with over the last few weeks so that you can take them home and geek out on your own.
Yeah, and this next story that I wish we had been able to geek out in is about a hybrid supercar.
Now, a hybrid supercar. There was a time not too long ago where the motorheads would just laugh. I mean,
hybrids are economical, fuel sipping.
It's the Prius,
yeah.
right? Or I'm sorry, what did the guys on Top Gear call it? The Prius? It's the Prius.
The Pri or something?
Yeah,
I don't know.
And they make fun of them because they're electric and they don't have the sound of a supercar. Well, there are a couple of manufacturers who have been playing with some hybrid drive systems, and it looks like supercars in the future. I mean, if you want a real supercar, it's going to have to be hybrid.
I mean, if you want to stick with your gas engine and be left behind, go for it. But if you want, to go faster,
hybrid. It's all hybrid. Specifically, this one is the Koenigsegg. I don't know if it's. I've heard Regera. I've heard Regera, but I'm going to call it the Regera. Koenigsegg is known for making some ridiculous supercars. In fact, they kind of busted the genre of supercars because supercars used to belong to, you had the Bugatti Veyron, you had everything from Ferrari and from Lamborghini.
Yep.
Then you had a Swedish automaker come in and kind of turn the world on its head.
With a really long, ridiculous name, too.
Koenigsegg. And people are like, Koenigsegg? And I think the breakthrough was when the guys at Top Gear took one around the track.
And they lost their minds.
They lost their minds. And they also did the same thing, which is it's a ridiculous car. I mean, it will kill you if you don't know how to drive, but it was ridiculously fast. The amount of power that you can put on the pavement with such a light body, with all that carbon fiber, was mind-blowing.
I think they were one of the first car manufacturers that pioneered like the carbon fiber reinforced Kevlar, everything, doors, frame, hoods.
And actually, good point. That whole Kevlar carbon fiber thing that they do, that's kind of the standard now. Everyone wants to copy that. Koenigsegg, I think their first car was like in 1994. Wasn't well received. I mean, it was them getting into the market, but then in 2006 they created the CCX, and that's the one that the guys at Top Gear took around the track.
That will kill you in an instant.
That will kill you in an instant. I mean, it was right up there with like the Pagani, the Zonda.
Oh, the Zonda,
that thing is crazy. And they had carbon fiber everything, carbon fiber wheels, carbon fiber Kevlar body panels, and they made their own engine. It was a in-house, 940 horsepower, or 795 horsepower, the first one.
Yeah.
And then they followed up with the Agera in 2011, and that one gave you a 940 horsepower engine with everything. Now, that Agera, I remember, again, I don't think they had it on Top Gear yet, but it does 0 to 100 in 2.8 seconds. It does 0 to 200 in 8.9 seconds, and 0 to 300 kilometers, by the way, in 14.53 seconds.
Okay, yeah, kilometers makes a lot more sense, but jeez.
Kilometers, that's what the rest of the world speaks.
What?
Yeah, I know, right? Now, last week, they rolled out the Regera.
Right.
And Tim Stevens took a look at it. Yeah, this is the hybrid, and oh my.
It looks so good, too.
It's sexy. This is a 1,500 horsepower supercar.
I think that's the older one, isn't it?
Yeah. Well, yeah, it's a slightly older body panel here. But this thing is only 3,589 pounds. So the curb weight is very, very low. It's got a 5-liter V8. It's, again, a custom in-house twin-turbocharged engine. Now, the engine itself makes 1,100 horsepower and 944 foot-pounds of torque. But they added 3 electric motors. So you've got 1 motor on the drive shaft and 2 in the rear wheels. Now, those electric motors add 400 horsepower and heap on a load of torque. The wheel motors have 192 foot-pounds of torque. The shaft motor has 221 foot-pounds of torque. And they also included a 9 kilowatt-hour lithium-ion battery pack. So you could drive this thing for 22 miles with nothing but electric power.
Wow.
Yeah. Now you know this. You know this. One of the things that every racer, doesn't matter if you're racing 2 wheels or 4 wheels, is going to come up with is you've got your engine develops torque in a very certain area of its RPM band,
right.
And it's not at the beginning,
right?
That's why you rev your engine a little bit to try to get more of the power to the wheel,
right? Because you got to get to that point where you're building up enough torque to give you the momentum to go forward.
Exactly, and supercars are not exempt for that. Now, what a lot of them have done, something like the Bugatti Veyron, will actually use 4 turbochargers, and those are air compressors that are actually driven off the power of the engine, not off the power of the exhaust, to force more air into the engine to try to develop that power faster.
More fuel, yeah, basically.
Which is more fuel, and you still have, the torque curve goes from 0. When you're not moving, it starts at 0, and then it builds up, and then it kind of peters off near its maximum RPM.
Right.
The nice thing about electric motors, and we know this from our quadcopter episodes, the torque starts at the top. It gives you all its torque at the beginning, and then it has a linear slide.
So you put those 2 things together, and you have maximum power along the curve. Yeah.
So it means that you've got 644 pounds of torque from 0, going up to 944 pounds from the gas engine at maximum RPM. So at any given time, your torque is going to, in any speed, at any power band, your torque will far outperform any other supercar.
Yeah, it's so cool. And I was researching the McLaren P1 earlier this morning after reading this article, and that also has a hybrid system, and it just makes other cars look like they're sitting still. Yeah. And it'll kick in the electric motor between gears, or if it's making it in turn and stuff, it switches back and forth.
Well, that's the thing. I mean, this is why the hybrid concept is all about racing now. Every team that's worth their salt is developing a hybrid system, because drag racing is one thing. Drag racing, you're only in that hole for that first part of the power band, and then you're in the power band, and you've got your maximum torque, and you can go down the strip as fast as possible. But if you're racing, you're turning, and every time you're turning, you're dumping off energy, and you've got to start over again. Well, if you've got a hybrid system, you don't dive back into the hole. It's like you've got full power the entire time. And you saw those YouTube videos where you could give a standard internal combustion engine car a crazy head start, and you're going to catch it. Even if you're not a great driver, you're going to catch it.
Yeah, so it's funny how hybrids kind of started out not being seen as a performance item, being seen as something environmental, and now it's still environmental. Like those supercars still, don't give out very much emissions, but they are so fast.
Can you imagine if you're driving around one of these Koenigsegg's, and again, for the first 22 miles, to the office, you're under pure electric power, and you're like, yeah, I'm an ultra low emissions vehicle.
Yeah, this does 0 to 60 in about 3 seconds.
It'll melt your face off.
Yeah, cool. Pretty much.
Oh, and one other cool thing. I saw this in the details. I want to see it actually work. They can do what's called torque vectoring. So because they've got an electric motor at each wheel, they can actually vary the amount of torque that you're using to help it steer the vehicle. Because that's another problem, which is when you're putting that much power to pavement, you tend to spin things. You snap off wheels and such.
Right.
But this can actually help keep your car true, exactly where you want it. So eventually with these supercars, I think the next advancement is going to be some super advanced drive-by-wire system. Yeah. Because it's getting to the point where we can't control all the power we can actually get down to the pavement.
Yeah, we're definitely at that point, and I think it's the Nissan GTR that has the system that will individually give each tire as much power as it needs or doesn't need to get traction as it makes a turn, which is the one that broke Jeremy Clarkson's neck in Top Gear.
Oh, so by the way, we talked to Leo Laporte, and he's actually going to buy us one of these. So thank you very much, Lee.
I think. You know, in case we break one.
Yeah, well,
because obviously we're going to break one.
Yeah. I'm sure they can't be too expensive, even though Koenigsegg's only going to make 80 of these.
Oh, you know.
How expensive could it be?
Not that bad, right?
Yeah, I'm going to have to wait for the technology to like trickle down to like a Subaru WRX. The next generation of Subaru will have some of this.
I want to see them do the Priuses are pretty quick as they are.
Off the line, a Prius is actually fast.
Right.
It's just after the line is.
Yeah, just let's put a turbocharged engine in it, you know, and really surprise people.
If we do like a 30-foot drag race, I will beat anything you've got.
And you can sneak up on people,
and I can sneak up on you. All right, so we will probably not be playing with supercars in the near future, but you know what we will be playing with?
Something smart?
Very smart. How about your home, but smart?
Make it smarter?
Make it smarter. Now, at CES, if you watched any of my coverage, you know that it was a lot about the smart home. I mean, we've had the promise of the smart home forever, right, Brian?
Yes.
I mean, back with the X10 modules, you could turn your lights on and off when you wanted to, and you know, maybe you had something on the door so that you could signal when someone was there. But it wasn't really easy to tie together systems. I mean, unless you could find all the modules that you wanted and all the features that you wanted from a single manufacturer, you probably couldn't get it.
Well, that's not the case anymore.
That's not the case, because we've got SmartThings. Now, what is SmartThings? Quite simply, SmartThings is a way to network all of your smart devices to get the smartest home possible. Now, they've got this. This is the Smart Hub. This is where it all starts. That's the device that will tie together the different networks from let's say, you've got your Nest, or you've got your drop cam, or you've got sensors for your doorways or your windows. Now, SmartThings does make a lot of sensors, everything from a water detection sensor, so you could put it in the basement to find out if you're getting excess moisture. They've got motion detectors, and they've got this. This is my personal favorite. This is the presence sensor. What this thing will do is if I put it on my person, it allows the smart home to know that I've come back. Now, you can program this using like IFFT to say, well, when you detect my presence sensor, turn on my Sonos so it's playing my music. Go ahead and turn the thermostat up to the temperature that I like it. Or, you know, maybe even activate some of the appliances that might be smart enabled. Really, the only limiting factor when you're using SmartThings is how smart you can be. Now, this is CNET's highest rated smart home system. It lets you control your lights, your locks, your thermostats, your home security, pretty much everything, and all through a single app. That's a single pane of glass, kind of the holy grail of smart homes. Now, as I mentioned, with SmartThings, you can customize the way that your smart devices talk to one another. You're limited only by your imagination and the number of modules that you want to connect to your appliances. You can set your lamps to brighten each morning. You can set your sound system to turn on when you've got a visitor. You can set the speakers to broadcast the sound of a barking dog if you want to scare people off. You know, if you're doing the whole antisocial thing.
Right.
Now, if you want, you can use one of these systems to turn your home into a smart home. And that's what we recommend. And if you're going to do it, why not use the product that was named as CES's 2015 Editor's Choice Award? Now, to get you started setting up your smart home right now, SmartThings is offering our listeners 10% off of any home security or solutions kit, and you get free shipping in the United States when you go to smartthings.com/twit. That's smartthings.com/twit, and use the offer code TWIT at checkout. SmartThings, smart home, right now. Boom.
What's next, Padre?
Well, I was just thinking, you know, we kind of left our folks with this. This is our.
Is that a quad?
It's a quadcopter. I know.
I haven't seen one of those on here before.
I don't know what this is. Yeah, but we did have a lot of people who have bought kits.
Yes.
And that's fantastic. We get to see them on Google+.
I went through a very deep rabbit hole last night when I went on the Google+ page. I was like, I'll check it out. I haven't been on here in a little while. I was going to spend like 5 minutes. I spent like 45 minutes just looking at all the projects and all the people.
There are people doing some amazing things.
Yeah, there's some cool stuff on there.
We have someone who he used Instamorph to like put a car body on his quad. I want to see it when it's fully painted, because I mean it's ridiculous things like that you go, that's so stupid, and then 5 minutes later you're like,
okay.
Well, maybe
that was
I could
pretty
do
cool.
That. It was kind of cool. Fine. But we understand that there are people out there with FPV250s who may you may be getting close to the end of what the original design, the stock design, can do. So what we'd like to do is to give you a couple of different mods that you can do to your FPV250 to take it to the next level. So let's go ahead and start it off. Alex, do me a favor and press that magic button.
The FPV250 from Hobby King is a tough, versatile, and fun 250 class quadcopter, but there are some improvements that could be easily made to increase the performance and durability of the craft. The most commonly made complaint about the FPV250 is the landing struts. We've used CA, hot glue, epoxy, and pretty much every kind of adhesive in an attempt to secure them to the frame, but the combination of constant vibrations and hard landings always seems to knock the struts off the arms, usually in flight. Our solution starts with small zip ties. We're using small ones because large ones are overkill and weight is our enemy. I bought a large can of them at a hobby store for about $3. Choosing ties and colors that reinforce my fore-aft color scheme, I ran them through the cutaways on the sides of each motor mount, then through the middle of the landing strut. It's a longer length, so you'll either need long but thin zip ties, or you can just double up by daisy chaining two of them together. I've used a few methods for zip tying the struts. The easiest is to run through the cutaway across the bottom of the motor mount, down the other cutaway, then up through the strut. This will give you a single zip tie across the strut, holding it to the frame while allowing it to flex under stress. The second method uses the same cutaways, but instead of running across the back of the motor mount, both lengths of zip ties are run up and across the strut. This gives you a more solid mount, though it may not give as much in a hard landing, and could therefore be more susceptible to snapping under load. No matter what method you use, you now have a way to keep those pesky landing struts attached to your craft. The second mod I would suggest for FPV250 pilots is to upgrade the power distribution harness. The PDH that comes with the kit is nice because it doesn't require any soldering, but the short power leads from the ESCs usually mean that the harness is dead center of where you want to mount your battery. If you mount the battery over the leads, the strap will hold the battery, but only loosely. With an uneven surface between the battery and the craft, it will tend to slip and slide. The same goes for those who mount the battery on top of the FPV250. Not only will it move in high G maneuvers, which is horrible for the stability of the craft, but it raises the center of gravity. What we need is a way to mount the battery securely on the bottom, and that means modifying the power distribution harness to clear the area. You'll need some heat shrink tubing, a soldering kit, wire clippers, wire strippers, a set of helping hands, and 4 sets of male and female 2mm bullet connectors. The wire I'm using is 18 gauge, silicone insulated with temp resistance up to 200 degrees. This is the same gauge of wire used in the ESC power leads and the power distribution harness. The first step is to cut 4 lengths of wire, 2 red and 2 black. You want each length to be approximately 2 3/4 inches, just enough to extend the forward ESC power leads to the rear of the craft. With your 4 lengths of wire cut, use a pair of wire strippers to remove 4mm of insulation from each end. Try to keep your lengths and strips as uniform as possible across all the wires, because you want the final installation to be tidy. Tin each end of the 4 wires, remembering to apply solder to the strands and not to the soldering iron. The bullet connectors we'll be using are the 2mm variety. We need 8 total, 4 female and 4 male. Essentially, we'll be making extension cords to lengthen the current power leads of the front 2 mounted ESCs. Clamp a female bullet connector into the helping hands and heat it until you can melt solder inside the mounting cup. Melt enough to create a small pool at the bottom of the cup, but not so much that it overflows when you insert the wire. Still applying heat with the iron, insert the wire and allow the tin tip to reflow before removing heat. Once the solder on the tip has remelted, remove heat and keep the wire still until the solder has cooled enough to harden. Repeat the process for all 4 wires, then move on to the male bullet connectors. The process is the same. Heat the connector until it's hot enough to melt the solder, partially fill the cup, insert the wire, allow it to cool. Now we need to shrink wrap the female ends of the wire. We won't shrink wrap the male ends because that would hinder their insertion into the power distribution harness, and because we'll be shrink wrapping the entire harness altogether. Cut 2 lengths each of black and red 1/8 inch shrink wrap, making sure to cut enough to entirely cover the bullet connectors plus an additional 1/4 inch beyond the connector. This additional length will give short protection and provide strain relief for the connector. We need to cut 2 lengths of 3/8 inch heat shrink tubing that will insulate the power distribution harness. You'll need about 1.5 inches of each color to cover their respective blocks. Disconnect all the power leads from the power distribution harness. Now connect the positive and negative leads from the forward ESCs to the extension wires that you just created, making sure that the heat shrink tubing covers the connectors entirely. Slip the red and black lengths of heat shrink tubing onto the harness and connect all of the leads to the rear of each power block. This isn't usually possible because the connectors are too thick when wrapped in heat shrink tubing, which is why we didn't shrink wrap the male connectors. Without the heat shrink, the bullets should all fit snugly into the appropriate block. Slide each length of heat shrink tubing back onto each block, making sure to cover all the connectors while leaving the front of the blocks accessible for future mods. The tubing should insulate the power leads while also ensuring that they stay snug in the block. Now it's time to make everything neat. Using zip ties, pull the new leads to the sides of the craft's belly. Snug the ties and you should have a clear undercarriage on which you can firmly mount your battery. I like to use a strip of Velcro on the belly and some Velcro on every battery pack in my inventory to hold the pack snugly. Combined with the Velcro strap, you should now have an FPV250 with a solid battery mount that won't allow shifting weight to disturb your flight. As an added bonus, the new location of the power distribution harness makes it easier to access the power connector and to run future power system mods.
Now, we started with these mods because these are the easiest to do. I mean, it's not going to cost too much.
My favorite is the zip ties.
Doesn't that change the way you fly it?
It helped a lot because before I was landing on the battery and my GoPro.
Well, the thing was, for me, they fell off so often no matter what I did with them that I just left them off.
Yeah.
So I would just like catch it in my hand, which that's not ideal.
No, not at all.
Yeah, and I've only had these things pop off once, and that was like that was the tree impact.
Right. Under normal landings, they're perfectly fine.
Yeah, exactly. And they give just enough where it'll flex left and right. So it's
has
like a
some
dampener,
give.
yeah, which is nice. But the big thing has got to be the battery placement. Seriously, that changes entirely the way that you fly your FPV250 because you know this, when the battery's loose, it shifts from side to side, and that throws your quad off balance.
It's always trying to compensate for it.
Always trying.
And it helps when if you are going to strap a camera or something to the front of it, then you can position the battery easily or more easily. It'll stay when you need to like balance out the quad, so the battery like goes further back and the camera's at the front.
Right. Oh, let's go and answer a really quick question because we get this a lot, and that is people are complaining that they go through I go through props a lot, so I understand what people are talking about. These snap with regularity when you hit things. That's what they do.
If you don't hit things, they don't break
they
so much.
They don't break, right. So, I mean, I typically go through like 10 of these things on a weekend.
A weekend?
I fly a lot. And I've
gone through one set.
Yeah, but I've gotten to the point where like I'm flying through obstacles now. Like
That's
I'm taking them through trees. I live at a school, so we have a lot of those hurdles. So I set the hurdles up like in an obstacle course at different elevations and then just go through
You like to give yourself a challenge.
a little bit of a challenge. Right?
Yeah. Well, there's not prop guards that you would get. You would rather just buy more props and put prop guards on it. Yeah.
No, you can buy prop guards. And actually, I'll show them off in a future episode. Ready to Fly Quads has prop guards that will screw straight onto this. And all it does is it gives like a perimeter so that you'll bounce instead of chopping off your props. But I don't like them because it changes the center of gravity. It like moves the weight to the outside, which means you don't pivot quite as quickly.
You're such a purist.
Well, I mean, it's more fun this way. Besides, it's kind of like a badge of honor. I have a box filled with the dead props.
Broken props.
Like, that's right.
You can tell when Padre's been out at the football field by like, where he is by the scattered props. It's like little breadcrumbs.
We had a security guard who was complaining to the administration of the school because kids were finding like sharp pieces of plastic on the field.
Where are these coming from?
So the superior comes to me and goes, "You wouldn't have happened to have left a bunch of broken propellers on the field, did you?" I'm like, "Yeah, that's me,
well, once they snap, they go everywhere."
I can't find them.
Yeah, especially cameras that you can't find too.
Yeah. I'm not talking about that. But I will say this: buy yourself a lot of props.
Yeah.
So I found
give yourself props.
But give yourself a lot of props. Exactly. I get the double entendre. But you're going to go through this with regularity. So if you could find a source online, like I found a place where I could get these for about $1 a pop.
Yeah.
And I just bought myself a full set. You know, I got like 100 of these things.
Have a bunch on hand.
Yeah, because it's not like I'm ever gonna not use them, not need them. I'm always gonna be breaking props. I'm always gonna need new props. And when you buy them in bulk, you can get them a lot cheaper.
Yeah. Well, I haven't had to buy any because you keep giving me props. So thank you.
Yeah. Now let's go and move off of our quadcopter segment. We last week looked at the first episode of Spinny. That's Mark Smith assembling his Arduino clock. It was a way to turn some old analog gauges into something that you could put into a beautiful steampunk design.
Yeah.
Now, we need to continue. We've got this episode and we've got next before you can have all the Arduino goodness to put together the hardware. But remember, you're going to have to go to Coding 101 if you want to find out how to do the software. So, Alex, if you'd be a great TD, please, and press the magic button.
So if you remember from our code, there are 3 pins that we used for switches and then three pins that we used for pulse width modulation outputs. I've got my code up right here on my laptop. Let's go ahead and hook up the buttons first. So the buttons, we use pin 2, 4, and 7. So we're going to hook up pins 2, 4, and 7 to each of the buttons. So we're going to bring 2 from right there all the way up to switch 1, and then 4 up to switch 2, and then 7 up to switch 4. So that will line up with minutes, seconds, and then calibrate. So I'm going to be trimming up some wires here. I'm going to start out by stripping a little bit off the end, and that is the part that we're going to put into the hole. Then I'm going to try and measure from pin 7 and go over to switch 4, and then cut a little bit extra here just so that we have enough. Pull that wire out, and then we are going to rig this up from 7 all the way over to 4. And just like that. So we have run a wire from pin 7 there over to switch number 4 there. And that's going to hook up the calibrate to pin 7. Flip it over and solder. Trim off the excess. We hear little bits of metal wire fly across the room. And then we're going to do the same thing to pin 4. Switch 2. You don't want to spend too much time with the soldering iron on these wires because they will melt the installation, especially when you've got 2 wires that are so close to each other right here that they might short out with each other if you're not careful. All right, one more. Switch, or pin 2 to switch 1. Good. Okay. Again, trim off the excess. We have rigged up, there it is. We have rigged up these 3 pins going over to those 3 switches. And so now that switch is rigged up to pin 7, pin 4, and pin 2, which is right where our software expects them to be. Now we're going to move on to the analog outputs. We're going to take these potentiometers and we're going to solder them onto the board. Now this board is a lot like the breadboard that we used, where each of the rows are all connected together. You can kind of see the solder bridges between those 3 pads, right? So if I put something here, it will automatically be connected to those 2 pads as well. So that allows us to put a potentiometer in there and get it to do what we want. But I'm actually also noticing that over on this row right here is all already connected to ground. So we are going to go ahead and hook up our resistors like that, so that I have access to all 3 of the pins of the resistor. I only need 2 of them, but I have access to all 3 of the pins of the resistor right there. And then I'm going to hook up all 3 of them like that. I'm going to use a similar trick here that I used on the headers, where I will solder in one of the pins to hold the board, the potentiometer in place. You get that. And I'm going to flip it over. See how it's kind of crooked? I'm going to reflow that solder, push that down, then remove the soldering iron, let it cool, and now that potentiometer is held in place and I can solder the other 2 pins without having to worry about it being out of whack. Cut off the excess. And we'll do the same for the other two potentiometers. If we didn't do this, then these extra wires would be hanging down and potentially touching parts of the Arduino that we don't want them to touch. And that could be very bad. All right, so now I need to hook up the input side of these potentiometers to pins 5, 6, and 9, which is where we got the PWM output. I'm going to go ahead and use a different color of wire so we know what each one is. I'm going to use red this time. Somewhat arbitrary, but it's what we have access to. I'm going to cut off or strip off a little bit of that. We just got little short jumpers that we need to do on these, so I'm going to make these short wires. And then just bend that in a U shape, like that. And then we're just going to jumper it from, what do we say? The first one was 5. 1, 2, 3, 4. Wait, 0, 1, 2, 3, 4, 5. There's the first one there. Maybe I need a little bit longer. Tell you what, I'm going to use this one for 6, which is going to be shorter. 6 goes to the first side of the middle potentiometer. I'm going to have to make a little bit longer of a jumper for the other one. But you can see how it goes into the first pin of the potentiometer. There we go. Thank you. Less glare. First pin of the potentiometer. So let's go ahead and solder that into place. I'm going to do a slightly longer jumper to get pin 5 into the first one. Okay, so I've got pin 5 going into the first pin of that potentiometer. Flip it over, kind of bend it out so the wire doesn't fall out, and solder that up. One more jumper. And this one is going from pin 9, which is right there, over to there. So it's going to be another short-ish jumper. If you've got big fat fingers like I do, sometimes it's easier to use your needle nose pliers to put these into place. Oop, wrong hole. Notice what I did? I put it in the hole that's between those two potentiometers. Got to make sure that you get things into the correct place. So I'm going to pull that out and bring it over there. And now it's in the hole on that first pot, or that last pot there. Okay, so what have we done so far? Well, we've put the pins on so that we can plug it into our Arduino. We have soldered in a reset switch so we can reset our hardware if we screw something up. We've got 3 switches up here that we can use for minutes, hours, and calibrate. We've got a red LED that we can use here for the ticking. We've got all of those switches hooked up to their digital inputs over here. We've got the 3 analog outputs going to the potentiometers. We have not hooked up the ticking LED. We should do that next. And we have not hooked up the output of the potentiometers to the analog panel meters. So that'll be after that. I don't know what's going on. I'm turning to... Sorry.
Nobody knows what we're talking about.
This is what happens when we're playing those.
In between videos.
Yeah.
Living like a... Okay.
No, sorry. Now we will be giving you part 3. So after next week, you should be able to have to be able to put together all of the meters that you need in order to make your Arduino clock. I'm actually going to do a couple of projects based off of Smitty's hardware. So I'm going to use the same software, slightly modified, and the same hardware setup to play with some LEDs. So this is definitely something that you're going to want to get. If you don't have the parts, go back about 3 episodes either in Know-How or in Coding 101, and go ahead and buy some of those parts. They're not that expensive. Arduinos can, the Unos will cost you, what, 20 bucks? Something like that. And the gauges can cost you between $1 and $10, depending on how fancy you want to get them. And then the parts, again, if you buy them in bulk, are really not that expensive.
Yeah, I've been enjoying watching these Smitty crossover episodes because they're maker projects, but you learn a little bit of code, you build something, and if you're following these projects, you're gonna like some of the Raspberry Pi stuff that we do later on.
Yeah, and Smitty mentioned this in the Coding 101 crossover, where he was saying that, look, it's all about taking inputs, finding information from the real world, processing it in some way, and then pushing it into an output.
Yeah.
Yeah, and that's what we're gonna be doing. Now we're doing it with Arduino. Let's go ahead and move on. We've got a couple of questions that we didn't get to last week because Alex was Alex.
Yeah, controlling the show again.
Control freak.
How much time do we have?
Yeah, Alex, can we do this? Is this okay?
Yes, we got plenty of time.
Oh, okay. Whew. Now we've got that.
Now, we have a question here from John Mink. He is a long-term member of the Google Plus community, and he had some networking issues that he was hoping we could help him with.
Yeah, so John asked, what's the best approach for connecting wired devices, parentheses desktops, when running Ethernet isn't an option? Renting an apartment, so he can't use any existing wiring, but he can't add his own. Is Wi-Fi the way to go, or some form of existing wiring better? He has number 1, AC, 2, coax cabling for TVs, and 3 phone lines, very short range DSL. Yeah, and this is actually a great question. We get this a lot from people who have either temporary installations or they're in a house that they can't modify. Right.
They don't want to go drilling through the walls or dropping things into the ceiling or down to the floor. Yep. Well, yeah, you've got options. The first one that he mentioned was AC. There's AC power line networking. I'm not a huge fan. It works most of the time. I have never, and I've been testing AC power line adapters for the better part of a decade. Yeah. I have never had a power line adapter that didn't eventually die. It's just, I mean, because you're plugging it into a system that is naturally not good for it.
What's the kind of life expectancy?
The longest I've ever had one last is about 2.5 years.
So if you're renting an apartment and you might not be there for longer than that?
It might work, but I mean that was a nice one. That was a high-end version.
Oh, okay.
A lot of the cheap ones, they'll die within a couple of months. Now the way that works is it's like the old X10 module. You're essentially sending a signal along the same lines that deliver power to your house. The issue with that is it has to be on the same circuit, so those signals don't go through a breaker. Yeah. And you also can't plug it into a surge protector or a power strip, which is probably one of the reasons why they die quite a bit. An issue for me, though, is the encryption on a lot of those devices is not great. So, like, if you live in an apartment building and you have a neighbor who's on the same circuit, if he or she was Snoopy, technically they could have access to your network.
Yeah.
I've done it.
Could be a little frightening.
It's not a huge issue, but I'm not a fan.
Yeah.
It's a possibility. It's definitely a possibility. It's very easy to do. I would probably put the other solutions ahead of it before I considered AC.
Okay.
The other one, so phone cabling for TVs, coax cabling for TVs.
Yeah.
Coax networking is fast and it's inexpensive. Problem is, if you have coax cable, I don't know why you wouldn't also have Ethernet cable, or at least the ability to have Ethernet cable.
Right, that's kind of the same thing.
Yeah, you can do it. You can find adapters for pushing Ethernet over coax, and I would actually take that over AC. If that's a possibility, then it's wired, and wired is good. I love wired.
Definitely, especially if you have multiple Skype guests on a show.
Yeah, how about that? Phone lines, very short range DSL. No, don't do it.
Okay.
I'm going to nix that right now.
Don't do it.
I've seen some interesting installations. They're too varied, and I've had way too many glitches with the technology. I had like a dozen products that I refused to review just because I couldn't make them work consistently.
So then it sounds like Wi-Fi.
My big thing is Wi-Fi, because you can make it really dependable. And if you are talking about a temporary installation, you're probably not looking at a super fast network. You can get decent throughput with Wi-Fi, and it will work pretty much everywhere. You just got to set it up properly. Now, what I've done here is I've got a DDWRT set up on a WRT54G. So this is the original. This is one of the guys that made DDWRT and custom firmware possible, because it actually had enough power, hardware power,
Right.
to be able to do some of these cool features that you would usually only get on advanced routers.
These little guys have been around for a while.
Yeah, more than a decade.
Yeah.
Since what, 2006?
Something
Like that.
It's kind of been around long enough that this is like the iconic look
This is
for
the
it.
thing, right? This is the thing. Now people see this and go, "Oh, I'm going to flash the firmware."
Right.
There's other firmwares, by the way. You can get like Tomato, you can get OpenWRT. I'm still a fan of DDWRT, probably just because I grew up with it and I know it really, really well. Now, Alex, if you go to the screen for this one, this is what the control panel looks like. Now, this is a super old version of DDWRT. This is from 2006. So, but the interface is basically the same. They've changed a few things, they've made a few things better, but it's going to work the same way. The features are going to work the same.
A lot better than the stock firmware.
Oh yeah, yeah. Dump the stock firmware almost immediately.
Yeah.
One of the things that you'll notice is if you go into the wireless tab here, under wireless mode, you get a couple of different options. AP is just like it sounds. It's an access point.
Yeah.
So it just makes a broadcast spot to which other devices can connect. But then we've got client bridge, and ad hoc. You don't get that in the basic firmware, at least of most routers.
Right.
Some now do it because they realize people want it, but DDWRT was the first one to really give us all these options. Client, what it will do is it will use the wireless like the WAN port. So it will connect to a wireless network with the onboard radio, and then it will NAT out to any computers that are connected to its wired LAN ports.
Okay.
Right. So, for example, I could go into Starbucks. I could set up my router on wireless on client mode. It would get the signal from Starbucks. It would create a NAT there, which is kind of nice because now it means the outside world or anyone in that cafe can't have access to my computers. And then I would plug my laptop into the wired port.
Right.
I wouldn't actually do that unless I was trying to be a nerd, but you could.
You might get a few looks.
You might get. Actually, the only way I would do that is if I also came in with a desktop and like a monitor and like set it up on the counter.
And the way I'm imagining you do this is with duct tape on everything, so you just got the router duct taped to the back of it.
It's in a shopping cart.
With your tinfoil hat on too?
Right.
Yeah.
And then when an employee comes over, I'm like, I got a coffee! I can be here! Okay, so that is useful you can actually have setups where that's a good thing. The one that's far more useful, Alex, if you go back, is this client bridge. What this will do is it will use the radio on my router to connect to the network like a client. And it basically just makes a bridge. It's a straight through bridge. If I connect something to the Ethernet ports on this client bridge router, I'm calling it a router. It's not really acting like a router anymore.
It's like a repeater, or?
Well, no, it's a bridge.
It's a bridge.
So it's
right.
allowing all those wired devices to access the wired network through that device.
Okay.
Yeah, it's a very useful. I do this a lot. In fact, most of my DDWRTs, because I have most of my WRT54Gs, because I still have like 20 of these things, they have set to client because it's a fantastically flexible way or client bridge to connect my wired devices to a wireless network.
Okay. Is it a good way of extending the range of your wireless network?
No.
No.
I mean, you can do it this way. What I have actually done is I have set up a pair of these things. So one of them will act as the bridge, and then I have one acting as a standard broadcast AP. And I do that so that I can get them far enough apart so that I'm not getting the traditional interference problem where I'm basically repeating a signal and causing a lot of interference.
Okay.
We'll go into that a little bit later.
Good.
Now, Alex, go ahead and go back to this. See, this is what you need. You need to be able to have the SSID settings, and of course, you're going to have your wireless security settings if you've got any. Hopefully you do, so that you're setting up this WRT54G to act like a client on the wireless network.
Right. Okay.
So everything you would need to access to connect your laptop to the wireless network, you're going to need to connect the WRT54G.
Yeah. So was it the SSID and the password?
Correct.
Yeah.
Yeah. So that's that. That's my preferred solution. I like doing it that way. It tends to work really, really well. But again, wired is always better than wireless.
Yes.
I mean, I can say that with very few exceptions.
It's gotten a lot better, but when it comes, for me, it's my desktop or it's my gaming device, I want to be wired.
Yeah. And by the way, I think I flipped the description of client and client bridge.
Oh. So...
I need coffee.
Let's go back to that Starbucks.
Let's go back to the Starbucks. We will be doing a special. I looked at the schedule and I realized it's been like 2 years since we've covered DDWRT. It was back in the day. So what we're going to do is we're going to do a DDWRT special. We're going to show you how to flash the firmware on your router. We're going to show you some of the advanced features. Like, for example, you can play with wireless power settings, and people have to learn how to do that because you can do it in a really wrong way and totally mess up your wireless network. We're going to show you how you can install things like a VLAN module so that you can segment out your network into like the private area and the guest area. We're going to show you some of the really cool advanced features for like installing OpenVPN. So if you have any hankering for network shenanigans, stay tabbed.
I want to extend the range of my Wi-Fi in the house.
No, you don't.
No?
No.
Oh, okay. Then I won't do that.
Oh, we got one more.
Oh, yes.
That's you.
From Ben Rees. He is asking about Arduino. Here's a little project he did a few days ago. His 15-year-old fridge door doesn't always close all the way. So he wanted an alarm to tell him when he or his wife, or I guess his 2-year-old son, leave it open. The switch is a few pieces of aluminum foil. It buzzes after 15, 30, and 45 seconds and beeps continually until the door is closed. That is pretty clever.
This is awesome.
And
I love this.
I have a fridge at home that does this exact thing.
Right. And look at that. I mean, it's literally contact points. So you need contact points on the input, and the Arduino takes care of the rest.
That is really clever.
Yeah, this is exactly what Smitty was talking about finding something in the real world that you want solved, and then figuring out how to do it with an Arduino or a Raspberry Pi.
Yeah, give yourself a project.
Yeah, and so do that. Folks, if you've got projects like this, we want to show them off. Just like with Ben Rees, find something, do something, show it off. We'll make sure your work gets rewarded. And you know what? Please jump into the Google Plus group and throw Ben some love because he did a real maker thing there. I saw what you did.
I promise you will get lost in there. There's a lot of cool projects and things that people have been posting and show ideas.
It's not all quadcopters.
It's not.
Sometimes it feels like.
No, it's pretty cool. Some of the frames and all the excitement people are having in there with the frames that they bought and the different props that they want to use and things like that.
My favorite part is that, I mean, if you go back a couple of months, no one was talking quadcopters.
No, yeah.
But now we've got enough people who have learned a lot, either on this show or other shows or just by doing it, where they can answer the questions for new quadcopter enthusiasts before either of us ever get in there.
Yeah.
And that's what I like. That's the community. That's the whole maker spirit.
Yeah, it's cool. It is. I got lost looking at I was looking at gyros for quadcopters, which then turned into gyros for motorcycles, which then turned into
motorcycle quadcopters.
Motorcycle quadcopters, but then I got down the rabbit hole of magnetically powered valves for engines instead of using a cam on an engine, and I thought that was pretty fascinating. So that's what happens when you start filling your head with knowledge. You just go down these different paths, especially on Google+.
The knowledge hole is vast.
It is vast and all-encompassing. Awesome. It is the universe.
Now, folks, I know that this was a lot of material, especially the mods for the FPV250. So make sure you go to our show notes page in order to get those show notes. We actually give you step-by-step procedures. Where are they going to find that?
twit.tv/KH. And if we're doing a project, we have all the links of where you can buy them, along with the price outs that you've put together. And there's also handy links for subscription. So if you have any device that you'd like to view this on or download to, we make it easy with a little drop-down menu. Yeah. And yeah, that's the show notes from last week. So they are
they get extensive.
They're extensive, but I wouldn't say they're overwhelming. Everything we talked about and handy links with the price on everything.
Oh, I should mention, people were pointing out the fact that those frames are kind of sold out on Amazon.
Oh.
There's actually, this is great though. It means there's a big demand. What I would suggest is actually eBay. I know a lot of people don't like eBay, but you can get a very inexpensive Alien X/Dead Cat frame from eBay right now, probably for a tiny bit less than you could get on Amazon. We won't be continuing that project for 2 weeks, so you still have time. In fact, this is why we spaced out the project so that people could get the parts in before we actually start the integration. So yeah, if you are just now seeing that list and you want to get on some of this quadcopter fun, go ahead and start buying your parts based on the list from last week's show notes.
Yep.
Yeah. Don't forget that you could also find us on Google+. Our Google+ group is fantastic. We can't talk enough about them. In fact, every episode we're trying to bring in more and more material from the Google+ group. If only our TD would let us do it. I mean,
it's all his fault. Always cutting us short.
I mean, you know, we got to start putting.
And he's turned the lights out on us.
Yeah, you know what? I've been told never mess with the people who control the buttons.
Wait until after the show to do
after
that.
the show, after the show. Also, if you're not into Google+, please jump onto Twitter. If you follow us, you'll get to see what we're going to do every week. We always make sure we preview it, and you'll be able to suggest topics for future shows. You can find me at twitter.com/PadreSJ. That's at PadreSJ.
And I am at cranky_hippo.
Yeah.
The show is out of control.
You're right, Brian.
He's got too
Brian.
much power back there. He's been saving all these little clips.
He's been messing up with that. I love it. I love it.
And that's Alex Gumpel, who you can follow at ANELF3.
ANELF3. Oh, by the way, if you could all please go to ANELF3. That's twitter.com/ANELF3.
Oh, he's going to cut you off.
And please ask Alex what he thinks.
There goes the mics. Get the mics. He's got too much power.
Until next week, where we will actually be talking about some tips for Windows. We're going to be finishing up the Arduino Clock project, and we're going to do a super special segment on balancing props, because now that we're getting to the big boys.
That sounds dangerous, Padre.
It's a little bit dangerous.
Could something go wrong if we don't follow proper safety procedures?
You could die, Brian.
That could be.
You could die.
That might be a little tease for next week.
Until next time, I'm Father Robert Balaser.
And I'm Brian Burnett.
And now that you know how,
go do it.
Actually, that's like an asteroid bouncing off one of my iron frigates.
It always comes back to homeworld for you.
So Brian, make that pun again about the props.
What was the pun I made? Oh, I gave myself props.
That was terrible.
That was pretty bad.
Terrible.